Today, I'm going to demonstrate how to find the centroid of a triangle. The centroid is located at the intersection of the medians, which connect the vertices of the triangle to the opposite midpoints. To begin, we will construct a triangle. We'll start with the segment tool along the left toolbar to create one side of the triangle. We'll use that same tool again and a third time to complete the triangle. Now we are going to select each of the points to label them. This top point we're going to label A, the left point will be B, and the bottom point will be C. Now we need to create the midpoints of each of the sides of the triangle. So we'll start with the segment AB. If we select the segment, then go up to construct, we can construct the midpoint. And we see it right there in the pink. Now we'll go to the segment AC and do the same. Construct midpoint, and we have that one as well. And then for BC, we'll do construct midpoint. Now we also want to label these points. So we'll go to the text tool. This point will be D, this point will be E, and this will be F. Now that we've created the midpoints, we want to verify that they actually are the midpoints. So we're going to create individual segments from each side of the triangle. So from B to D and from D to A. Now we're going to use the measure tool. So the segment BD, to measure how long it is, we're going to go to measure length. And we see that the length of segment BD is 3.68 centimeters. Now the segment DA should be 3.68 centimeters as well. We just want to verify that. So we'll go to measure length and see that it is 3.68 centimeters. Now we're going to go ahead and do that for the other two sides just to verify that we do have the correct midpoint. So we'll connect A to E and E to C using the segment tool. Then we'll go ahead and measure each one. So A to E, measure length. And we see that A to E is 4.67 centimeters. And then the segment EC will do measure length, and we also see that it's 4.67 centimeters. Finally, we'll construct the segments BF and FC. We'll go ahead and do the exact same thing with measuring them. So BF, measure length, we see we get 4.73. And FC should also be the same. We'll do measure length, and we get 4.73 as well. So now that we've verified that each midpoint we created is actually a midpoint, we can go ahead and create the centroid. So we do that by using the segment tool, and we're going to connect every vertice with the opposite midpoint. So C is the vertice, and the opposite midpoint is D. That's our first segment. So the next one, we'll go to the vertice of B, and its opposite midpoint is E. And then we'll go ahead to the vertice A, connect that to the opposite midpoint of F. Now the intersection of all the three segments we just created is going to be the centroid. So we want to create a point there. To do that, we want to create the intersection point. So we're going to select two of those segments. Doesn't matter which two. We'll go ahead and select these two. And we're going to do construct intersection. So we now get this point as the intersection, which is called the centroid. So we'll go ahead and label that. Right now it's named as G, but we can double click and the label we can change. So we're going to type in centroid, just so we know that that is the actual centroid. So now that it's labeled there in the middle, we have the centroid. Now to verify that that's actually the centroid, if we move points A, B, and C around, that point should remain as the intersection between those three segments. So let's move point C, and if you notice, the centroid is sticking with as the intersection of those three segments. We can similarly drag point A, and the centroid remains as the intersection of the three segments in the middle. And similarly with point B, it remains as the centroid. So we verified that that actually is the center. So once again, the centroid is located at that intersection of the medians, which connect the vertices of the triangle to the opposite midpoints.